So we'll see now the shape test. Now the aggregate shape plays a very important role in load transfer characteristic. We see a bituminous mix, right? In the bituminous pavements or flexible pavements, the load transfer mainly happens through aggregate interlocking. So if you have a very proper interlocking, then what happens? You get a very better load transfer. And if you don't have if you have very bad interlocking or very poor interlocking, there are chance the mix may be unstable, right? So this interlocking depends on the shape of the aggregate. If you have very good angular shape and cubical shape, you can expect a very good interlocking. If the shape is not cubical, if it is rounded or if it is flaky or elongated, the aggregate may undergo degradation during compaction process, and this may affect the gradation and it will be subject to degrading. Similarly, if you take rounded aggregates, the rounded aggregates may not be having proper interlocking, right? They will become unstable during the compaction process or when they are serving the traffic. So if you see typical shape aggregates, we will be having angular aggregates, then we have rounded, then we have flaky, then we have elongated. Now if you want to expect a very good interlocking, we always prefer angular aggregates so that we get a very stable mix. Similarly, on the other hand, if we go for this kind of aggregates, rounded, flaky or elongated, they may create some issues during construction and we will not be able to get a very good bituminous mix during the pavement construction. So if you see this particular aggregate, so this, if you see this aggregate compared to other dimensions, this is very long. This is a typical example of aggregate which is elongated. Similarly, if you see this particular aggregate size, this is like a plate-like, what you call as flaky aggregates. Compared to other dimension like width and the length, you can see the thickness is very low. So what happens while compacting, this aggregate can easily break, and then this can turn into two pieces which can further affect the compaction process. But with this particular aggregate, this is a typical angular or cubical aggregate where you can expect a very good interlocking while during its service life. This way, the aggregate shape plays a very important role in the mix performance. So to determine the aggregate shape, we conduct two tests called flakiness index and elongation index. So now from this we determine the percent of flaky aggregates and percent of aggregate which are elongated. So normally allowance of 30 to 35% is made. This is the maximum percent allowed. Maximum value of these aggregates allowed in a given aggregate lot. Preferably, most of the aggregates will be having, or it is preferred to have something less than 15, so that we can ensure a better, good quality of aggregates. Now, we saw that this is typical flakiness gauge. Now, similarly, as I told you, there are certain openings. Now, this opening has a particular meaning. So, we will see what is the opening meaning. So, now, we draw the figure. So, this particular slot, this slot is for 60 mm, 63 mm passing aggregate and 50 mm retained aggregate. So, this slot is 50 retained and 40 mm passing aggregate. So, now what this particular dimension is indicating? This dimension is basically indicating this will be equal to, right? So 63 plus 50 divided by 2 into 0.6. Similarly, this width will be 50 plus 40 divided by 2 into 0.6. And similar way, this will be 40 plus 31.5 divided by 2 into 0.6. This we can define the flakiness aggregate or flaky aggregates as who have dimension or this smaller dimension less than 0.6 times the average dimension. It is 63 plus 50 by 2 is the average dimension, and by 0.6. So any aggregate having thickness less than this will be passing to the particular sieve slot, and the particular slot and accordingly it will be a flaky aggregates. In similar manner, any aggregate passing through 50 mm sieve and it is written 40 mm aggregate, the average dimension will be approximately 45, so into 0.6. So any aggregate passing through this particular sieve thickness wise, then it's a flaky aggregates. In this way we will classify the flaky aggregate in this particular flakiness gauge. This particular elongation index, we saw there are certain openings here. So now what is the length or the width of this particular opening? It's a particular meaning, so we'll see what is that opening meaning. So now if we draw the particular diagram here, you can see it is 50 mm sieve passing and 40 mm sieve retain aggregate size. This is 40 passing and 31.5 retain and 25 passing and 20 retain. This particular opening length will be basically equal to 50 plus 40 divided by 2 is average into 1.8. This opening will be 40 plus 31.5 divided by 2 into 1.8. So from this we can define elongation aggregate or elongated aggregate. So elongated aggregate means basically, so the largest dimension, right, which is more than 1.8 times average dimension. This way we can see this will be around 81 mm, this will be around 64 mm. So whichever aggregate which is passing through 40 mm and 31.5 mm sieve and having a length dimension which is more than 64 mm, then it will be an aggregate which can be classified as elongated aggregate. Similarly, an aggregate passing through 50 mm sieve and returning in 40 mm sieve and which is the length dimension more than 81 mm, that can be considered as an elongated aggregates.